What stage is this project and what are you currently working on now?
The current stage of the project is at Waka, meaning that the windows are on, roof's on. It's basically ready for chip blocking, just waiting for the air conditioning people to put their ducting in and their motors. Balconies have been waterproof, so they're ready for tiling.
What is the scale of the project and how many workers are on the site at any given time?
The amount of people we're having in here could range from 2 people to about 16 to 18.
What kind of machinery will you need to finish this project?
The main machine at the moment would be this machine here, which is a Bobcat, which we're using as a forklift, which we bring material up and down this steep driveway, as you can see, and a crane. We will base a mobile crane on where this vehicle is at the moment, and this will actually take up our material for tiles, sand, cement, other building material, fencing. Everything basically gets shipped up by crane. The idea of this driveway is for that purpose only. That's why it's finished now, concrete. So we can actually manoeuvre.
Why did you choose to use a boom pump for this particular site?
Various booms, sometimes boom pumps, sometimes line pump, depending on the reach. If it was this driveway you see here, this was done by a line pump. So once we started getting up higher, it was too difficult to use line pumps. Line pumps are very cost effective, they're quite cheap. Whereas a boom pump, they can range from $1,500 to $1,800 just a minimum 4 hours. Whereas a line pump is down from $800 to maybe $1,000. So you always try to use a line pump because it's more cost effective.
Where are you storing materials and why have you chosen to store it?
We store all our materials, some of the materials on the outside of the driveway, but a lot of our tools and sand and cement get stored outside here, and then everything else, our tools are actually inside our garage. It's where we use as a lunch shed as well.
What kind of restrictions were placed on the project?
There was an Aboriginal cave, which may be of some significance. They can't determine if it is or is not. So they assumed the worst, and we actually had to build over this Aboriginal cave. Apparently it took an extra year and a half for it to go through council because of the report that had to be produced and the redesign of the architectural and engineering drawings.
Can you outline what happened in this photo?
That's the back wall, which was shotcrete. It had rained 2 days before, and there was some subterranean water which was oozing through that particular wall. So the renderers expressed it to make sure the water came out from that area, and then we repaired it later on.
I'm Daniel Markovic, and I'm with UTS Construction Technology. So what kind of foundations did you guys encounter on this?
Rock.
Yeah, just rock?
Just rock. Rock. We had some soil, but we actually removed the soil, and we just ended up with rock.
So how did you guys manage to deal with it?
We actually just had to use rock breakers. We used, I think, a 16-ton excavator with a rock breaker and a rock saw to actually just carve up the site and cut and also fill some certain areas, like this area where we're standing on was fill, where we could use some of the fill instead of exporting it off-site. It costs money to actually transport and dispose of. We try to use as much of the material we can use on site.
Would you say the scaffolding is supported in the best, safest way?
On rock, it's fine. You've got no problem. You don't need sole plates for rock. So even a brick or anything which will basically, as long as it's not compressible, it'll be fine.
What kind of temporary services are you guys using?
Yeah, temporary services. We've got power, we have water, we makeshift toilet. We did have a portable toilet, but once we had sewer and water on site, we've actually made a makeshift toilet inside the premises.
What type of bracing is being used on the wall?
Speed bracing.
Speed bracing?
So yes, it's speed bracing. So you could speed bracing, and I thought I saw up there a bit of ply bracing as well. Okay, and that's determined by the engineer. He will come inside and say, look, I want some extra bracing here, I want some ply bracing here, and so forth. But most of the time, 9 times out of 10, it's mainly speed bracing.
Would you know the reasoning behind using those braces, or is it the
engineer? Just engineer. It's usually the engineer. Like if he feels like there's not enough. If you've got enough internal walls, that's actually enough bracing in itself. But then if he looks like it's a bit, could be a bit more load on there with wind and so forth, he'll determine what type of brace he can. Okay.
Do you guys know what kind of loads you guys will have to work with?
No, the only one is wind. So I know because we're in an exposed area here, it's a wind category of N3. Okay, and because it's exposed, so it's a certain type of pressures that can actually be imposed on the windows.
That's all the questions we have. Thank you.
No problem.
Hi, I'm Marcus Couchy and I'm here with George Ostovich, Construction Manager of Australian National Builders. Can you describe the process?
It's a concrete pour of a garage slab in Mulgower. It's a residential site. It's a concrete pour of approximately 70 odd square metres. Concrete's been supplied via a boom pump, and it's being spread by 4 concreters, consisting of one man on a screed. He's the guy levelling the concrete with a long level stick, and then you've got 2 guys supporting him with shovels. The other one is got like a large rake or a hoe, and they're basically supporting the guy with the screed. And then there's one guy with a laser level, and he determines the level of the concrete at certain areas. There's also another person with a vibration pump, a vibrator, he actually helps level the concrete and also compacts the concrete, removing the air bubbles in the concrete, so we actually have good dense concrete.
And why did you decide to carry out this process using the boom pump?
Yeah, it's just a quicker process. Less likely to have damage to the slab or basically to the work they're doing. It's because it's a garage slab. We want to make sure that the concrete is poured evenly and there's a good finish on it.
What does a good concrete pour consist of or look like when it's finished?
Well, for this instance, because it's a garage slab, the slab is going to be, it's basically, concrete's going to be the finished product. So you just make sure that it's got a good, nice shine, basically level. It has a bit of grit to it. So they would have used, after this process, they would have used a helicopter to level the concrete, give it a good shine. Basically, good concrete is it's compacted well, not too much water in the water-cement ratio. That's basically it.
What are signs of a bad concrete pour?
Bad concrete pour, too much water in the concrete. It'll take a while for it to go off. It's not levelled properly and not compacted properly. You can't get access to it.
If you had a problem with it,